a signal from deep space, a planet that surpasses all expectations and a competition to another star. What if everything we thought we knew about the universe is about to be shattered? The James Webb Space Telescope, JWST, has discovered shocking secrets that could rewrite the rules of life itself. But is Proxima B truly a new Earth, or a deadly trap in the vastness of space? The James Webb Space Telescope, often hailed as humanity's most advanced instrument in the sky, has recently shifted its focus to one of the most intriguing exoplanets ever discovered, Proxima B. This faraway planet, orbiting the red dwarf star Proxima Centauri, has captivated scientists and enthusiasts alike since its discovery. But now, with the unparalleled capabilities of the JWST, we are finally getting a better understanding of this enigmatic planet, and the revelations are nothing short of extraordinary. Proxima B was first detected in 2013, but it wasn't until the James Webb Space Telescope came into the picture that we could truly savor the contents of this faraway world. The telescope's ability to record infrared images has allowed astronomers to peer into Proxima B's atmosphere, revealing information that was previously hidden from view. What they found has left scientists both excited and worried. Proxima B orbits its star at an extremely close distance, just 7.3 million kilometers away, which is less than 5% of the distance between Earth and the Sun. This proximity means that the planet completes a full orbit in just 11.2 Earth days. But what makes this even more fascinating is that Proxima Centauri, the star it orbits, is a red dwarf. Unlike our Sun, which is a relatively stable star, red dwarfs are known for their volatile nature, often emitting powerful solar flares that can drastically affect the planets orbiting them. Now here's where things get even more interesting. The JWST has provided the clearest view yet of Proxima B, and it has revealed some startling features. For one, the planet is approximately 30% larger than Earth, signifying a stronger gravitational pull. But what's truly shocking is the possibility that Proxima B is tidally locked with its star. This means that one side of the planet is in perpetual daylight, while the other is shrouded in eternal darkness. A world where no one ever sees the sunset, while the other side is thrown into an endless night. This tidal lock creates a harsh environment for any potential life forms. The side facing the star, Proxima Centauri, would be scorched by constant radiation, while the dark side would be a frozen wasteland. This raises a critical question. Could life ever endure such extreme circumstances? The possibility appears slim, but nature sometimes surprises us. But the challenges don't stop there. Proxima Centauri itself poses a significant threat to the habitability of Proxima B. The JWST has revealed that the star is much more energetic than previously thought. Its powerful magnetic fields bombard Proxima B with high-energy radiation. In fact, a flare observed in April 2021 was 100 times more powerful than any flare ever seen from our Sun. Such a massive burst of energy could strip away the planet's atmosphere, leaving it exposed to the harshness of space. Some researchers argue that proximity to its star and the frequent solar flares make it unlikely to support life as we know it. Others, however, suggest that life might find a way to adapt to these extreme conditions. Could there be organisms on Proxima B that have adapted to such a volatile environment, or is the planet doomed to remain a barren rock devoid of life? As we continue to explore Proxima B utilizing the James Webb Space Telescope, more of its secrets will be revealed. It is evident that this tiny planet, only 4.2 light-years away from us, is far more complex and enigmatic than we ever imagined. Could it be that Proxima B holds the key to understanding the limits of life in the universe? And if so, what does that mean for our search for extraterrestrial life? Proxima B's stunning secrets were revealed, and one of the most shocking discoveries was the planet's atmosphere, or rather, the potential lack thereof. The intense radiation from Proxima Centauri, combined with the planet's close orbit, means that Proxima B receives an incessant stream of solar wind and high-energy particles. Over time, this relentless assault could have stripped away the planet's atmosphere, leaving it barren and exposed to the cold vacuum of space. But here's where things get interesting. Some scientists believe that Proxima B might still retain a thin atmosphere, possibly composed of heavier gases like carbon dioxide or nitrogen, which could provide some protection from the star's radiation. The James Webb Space Telescope has given us the most precise view of Proxima B yet, and what it has revealed about the planet's surface is both fascinating and mysterious. The planet's surface appears to be rocky, much like Earth's, but with significant differences. For instance, the side of the planet facing Proxima Centauri is likely scorched by constant heat, creating a barren, desert-like landscape. Meanwhile, the dark side of the planet could be an ice-covered desert, with temperatures plummeting to levels far colder than anything experienced on Earth. But the most intriguing possibility lies in the narrow strip of land between these two extremes, known as the twilight zone. This area, where day meets night, might offer more temperate conditions where liquid water could exist. The existence of liquid water is, of course, one of the key ingredients for life as we know it. Could this twilight zone harbor a hidden oasis where life has managed to take root despite the harsh conditions on the rest of the planet? Another stunning discovery scientists have made is the possibility of water on Proxima B. If water exists on the planet, it would likely be in the form of ice on the dark side or small, possibly temporary, bodies of liquid water in the twilight zone. But the discovery that shocked many was the potential for subsurface oceans, like those on Europa or Enceladus in our own solar system. These oceans could be heated by the planet's core, or by tidal forces caused by Proxima B's close orbit to its star. If such oceans do exist, they would be a prime location to search for life hidden beneath the planet's icy surface. But let's not forget the potential challenges. The magnetic field of Proxima Centauri is another factor that adds complexity to the planet's environment. Recent studies suggest that the interaction between the star's magnetic field and the planet's core might generate its own magnetic field. This interaction could protect the planet's atmosphere from being completely stripped away by solar wind, much like Earth's. We are shielded from the sun's radiation. However, the situation on Proxima B is far from straightforward. Powerful flares from the star could overwhelm the planet's magnetic defenses, resulting in sudden and dramatic changes in the planet's climate and surface circumstances. These discoveries raise more questions than answers about Proxima B. How strong is its magnetic field, and how does it influence the planet's atmosphere and potential for life? Could life on Proxima B have evolved to survive the harsh, fluctuating conditions? If life does exist, what form would it take? Would it be something completely distinct from anything we've seen, or could it share similarities with extremophiles that thrive in Earth's most inhospitable environments? A hostile world where life faces extreme challenges, Proxima B is far from the captivating idea of a habitable planet in the Proxima Centauri system. The reality is far from hospitable. The James Webb Space Telescope has provided unprecedented insight into the difficulties that any potential life on Proxima B would face, and the picture is anything but rosy. One of the most significant challenges is the planet's exposure to extreme levels of radiation from Proxima Centauri. Unlike our Sun, Proxima Centauri is a red dwarf star with a much smaller mass and a much more chaotic surface. This star's proximity indicates that the planet is constantly bombarded by intense solar radiation, such as massive flares that can be 100 times stronger than those emitted by our Sun. These flares produce a lethal combination of ultraviolet and X-ray radiation that would be deadly to any form of life similar to Earth's. The effects of this radiation are not just theoretical. In April 2021, a particularly massive flare from Proxima Centauri was detected, and it was strong enough to potentially strip away any atmosphere that might have existed on Proxima B. This event serves as a stark reminder of the dangers posed. by red dwarf stars and casts doubt on the potential for Proxima B to serve as a haven for life. Moreover, the constant exposure to such radiation would make the surface of Proxima B a very hostile environment. Any surface water would be rapidly vaporized, and the rocky terrain of the planet would be scorched by the relentless heat. The dark side of the globe, without being exposed to direct radiation, would be equally inhospitable because of the cold temperatures. This extreme difference between the scorching day side and the freezing night side leaves little room for a stable, life-sustaining environment. The race to reach Proxima Centauri begins. Whereas Proxima Centauri's signal remains a mystery, the idea of actually getting to the stars has moved from the realm of science fiction to genuine research efforts. The Breakthrough Starshot Initiative, spearheaded by a team of visionary scientists and backed by prominent figures like Stephen Hawking and Yuri Milner, aims to send tiny, laser-propelled spacecraft to the Alpha Centauri system, including Proxima Centauri, within our lifetimes. The concept behind Breakthrough Starshot is as ambitious as it is revolutionary. The plan involves launching thousands of tiny spacecraft, each about the size of a postage stamp. These star chips would be launched into space, driven by powerful lasers, reaching speeds of up to 20% of the speed of light. The goal is to send the spacecraft on a decades-long journey to Proxima Centauri, where they could send back data about the star system and its planets, including Proxima B. While the challenges of such a project are enormous, the potential rewards are equally vast. Discovering the true nature of Proxima B, whether it harbors life or is a barren, hostile environment, could have significant implications for our understanding of life in the universe. What if Proxima B, this strange and volatile world, holds the key to comprehending life in the cosmos? The hunt for extraterrestrial life is one of humanity's most profound quests, but as we learn more about Proxima B and other distant worlds, we are confronted with the realization that life might not look like we expect. In the end, Proxima B may not be the Earth-like paradise we imagined, but it could be an important first step in our quest for knowledge about the cosmos. The universe's search for life is only just beginning, and Proxima B is leading the way. But the question remains, will we ever have the ability to decipher the secrets of Proxima B? Only time and continued exploration by instruments like the James Webb Space Telescope and projects like Breakthrough Starshot will tell. Perhaps Proxima B, with all of its difficulties, is not merely a planet to be studied, but a window into our future. The search for life, whether in our own solar system or on faraway exoplanets, is a reflection of humanity's innate curiosity and desire to understand the cosmos. The discoveries made about Proxima B could shape the next generation of space exploration, providing crucial insights into the possibility of living on distant worlds. Even if Proxima B proves to be hostile to life as we know it, the lessons we learn from this exoplanet could have profound implications for other planets out there. We may one day find worlds that are more hospitable, more like our own Earth. Worlds where life has discovered how to thrive and survive in the most difficult of environments. The quest for knowledge will continue, and as we push the boundaries of space exploration, we will no doubt uncover even more mysteries that will challenge our understanding of the universe. In the end, Proxima B serves as both a symbol of the challenges we face in exploring distant worlds and a reminder of the incredible possibilities beyond. It lies as a planet that might or might not contain life, but its significance lies in the questions it raises and the adventure it motivates. Through ongoing advancements in space technology and with instruments like the James Webb Space Telescope, we are closer than ever to answering one of humanity's most profound questions. Are we alone in the universe? The search for life may one day lead us to Proxima B or even further into the depths of space. If we discover life, whether microbes or something completely distinct, we will have taken a monumental step in understanding the vast, mysterious cosmos, most of which we are just beginning to explore. Whatever the outcome, Proxima B will continue to be a touchstone for our goals, guiding the next wave of scientific discovery and exploration for generations to come.